So here are some examples of solving the prediction intervals. So the scenario is, let's say that the students wants to predict their scores in the next math test based on their previous test scores. So ang ilang past scores kay 78, 82, 85, 79, and 81. So for solving the mean, let's add each numbers and divide it by 5 because lima man sila kabuok. So ato siya divide by 5. So ang answer kay 81. So for solving the standard deviation, the mean kay ato siya i-minus sa each numbers and square nato siya, then by solving this, iguman to solve ani kay ato siya divide by 5 kay since 5 sila kabuok, then ato siya square root. So ang answer kay 3. So for solving the prediction interval calculation, suppose that the students wants a 95% prediction interval. So ato'y assume ng students kay ganahan og 95 na percent sa ilang prediction interval. So this is the general formula for solving the prediction interval. Prediction interval equals mean positive negative t times standard deviation times square root of 1 plus 1 over n. So ang kaning t kay mo siya ang t value which is the 95%, and since we want in between, so atong gamiton kay 2%, ay 2. So let's plug the numbers. So prediction interval equals 81. So ang 81 mo na siya ang atong mean. The 2 is the prediction interval percent, which is we assume that it is 2, and the 3 is the standard deviation. Then the square root of 1 plus 1 over 5. So 5 it is the n. It's the muna siya ang numbers kung pila ka buok ilang past scores. So ato siya gi-solve. So ang yang square root kay muna siya. Yang ato ni siya i-multiply. So it is 6.55. So ato siya i-solve. So ang in between niya kay 74.43 and 87.55. So it will be fall between these two numbers. So this is the prediction interval of the students for their upcoming test scores.
So, what is prediction intervals? So, prediction intervals is an interval quite predicting a future observation with a known mean, with 1 minus alpha percent of confidence from a normal population. So, we had two formula. So, first is when sigma is known, and second is when sigma is unknown. So, since sigma is known, so we're gonna use a z-score in a formula and a sigma. So, sample mean plus or minus special z times sigma times square root of 1 plus 1 over n, or n is sample size. So, since sigma is unknown, so we're gonna use S, or known as sample standard deviation. And since we use a t-score or t-table here, so we're gonna find its degrees of freedom, where in finding the degrees of freedom is df, or degrees of freedom, is equals n minus 1, or n is a sample size. So after this, so we're gonna apply these two formulas in our examples. So let's start. Example 1. A random sample of 100 crickets was taken from a normal population in 60 degrees Fahrenheit weather. The number of chirps per minute was observed for each cricket, and it was found out that their chirps per minute was 78. Find a prediction interval for the chirps per minute of next cricket observed if it is known that sigma squared is equals 1.44. Let alpha be 0.05. So first, we're gonna write our formula, which is PI, or prediction interval, is equals to x bar plus or minus z, or special z, times sigma, or standard deviation, square root of 1 plus 1 over n, or n is our sample size. So first is, it is right, that one. So PI So let us try to give the given, or let us try to get the given. So the givens are, so since we already had the sample mean, so sample mean is equals to, or x bar is equals to 78. And since our sigma has its exponent of 2, so we're gonna square root it, or square it. So sigma to the power of 2 is equals to 1.44. So let us try to square it. For the sigma squared will become 1. So let's square root this both. So sigma squared becomes sigma, and 1.44 square root of 1.44. So square root of 1.44 is 1.2. So since we use a z-score or z table, so we're gonna get the z value, or the critical value of z, using this equation. So we're gonna use what is in the formula. So like this, we're gonna use this. So z, or special z, alpha over 2. Since alpha is 0.05, so we let z 0.05 divided by 2. So it's equals to 0.05 divided by 2. So this becomes 0.025. So our z value, or z is equals to 0.025. Since we had our z, so we can get the value of z, or the z-score. So z-score, so in finding the z-score, so we must subtract it to 1. So z is equals to 1 minus 0.025. So if we calculate this will get 1 minus 0.025, we will get 0.975. 0.975. So this value is our z-score. So let us write about z-score. Since we had the z-score, but what we will find is the critical value. So in finding this, so we can use the z-table. So at z-table, we can get the critical value, or which section is 0.975, we will find. So the critical value value of 0.975 is, or it can be located in 1.96. So 1.96 is our critical value, so z is equals to 1.96. And I almost forgot that we also need our sample size, or size of the sample. So n, or some others use a small n or capital N. So I will just put this both. N is equals to 100 crickets. So since we all had the given needed in our formula, so we can now plot it. So since our formula is pi, so we can directly put the given below. So is equals to, so our sample mean, which is x bar, so it becomes 78 plus or minus, so the critical value of z is 1.96 times our sigma is 1.2 times square root of 1 plus 1 over n, or n is our sample size, so 100 or 100 crickets, so just put 100. So let us calculate this. So the result of this, if we will calculate using our calculator, so 78 times, plus 1.96 times 1.2 times square root of 1 plus 1 over 100. So we get a 80.36%. So the result is 80.36%, or 80.36% prediction interval, or chirps per minute. Per minute of the next cricket. So this is the answer. So 80.36%. So this is how to calculate or solve, or how to get the prediction of a prediction interval when sigma is known or standard deviation is known. Example 2. Paint drying time follows an approximately normal distribution. So the given points are 3.4, 2.8, 4.4, 2.5, 3.3, and so on. Find a 95% prediction interval for drying times of next trial of paint. So, since sigma is unknown and our n is not large, so we're gonna use s and calculate for s and x bar, or our sample mean. So we're gonna use the second formula. So the second formula, which is pi is equals to x bar, or our sample mean, plus or minus p, or the special t, or represents the t table or t score. So alpha over 2 times s, or rs is our sample standard deviation, times square root of 1 plus 1 over n, or n represents the sample size. So since we don't have our S or sample standard deviation and our sample mean, so we're gonna calculate it or we're gonna find it. So in order to find the value of S or sample standard deviation, we have this formula. So I'm gonna write this to the right side. So this represents this side is how to find the our sample standard deviation. So we had this formula. So S or standard deviation is equals to summation of the difference between every point in a data set and a sample mean. So x minus x bar. So x bar is or which the average of the given point. So first thing is we also need to find the sample mean of this. So let's look forward and squared divided by n minus 1 or sample size minus 1. Then we're gonna put is with the square root. So this is the formula in finding the S or sample standard deviation. So first is we need to find the sample mean. So in order to find the sample mean is just the x bar is equals to the sum of all numbers. So we must sum all the given points, so which is 3.4 plus 2.8 plus 4.4 plus 2.5 plus 3.3 plus 4.0 plus 4.8 plus 5.6 plus 5.2 plus 2.9 plus 3.7 plus 3.0 plus 3.6 plus 2.8 plus 4.8. So the sample size of this, so we can already count it. So 3, 3, 3, 3, and 3. So sample size is n is equals to 15. So the sum of this is all over to 15, or how many numbers or how many variables. So n or 15. So we're just gonna add this also is equals to 3.4 sorry so the summation of all of this is 56.8. So 56.8 divided by 15. So our sample mean we can get is 56.8. So we can directly divide it by 15. So divided by 15. So what we can get is 3.7866. So since at the fifth decimal number is 6, so we're gonna round off the fourth decimal places. So it becomes 3.7867. So 3.78867. So this is our sample mean or our mean. So since we had our sample mean or x bar, so we can now proceed to the formula or the formula of standard deviation. So this. So but before that, so as we see that first is we're gonna get the summation of the difference between every point minus, or the summation of the differences between the every point between the sample mean squared. So what we're gonna do is each is, so first is 3.4. We're gonna minus it or subtract it to 3.7867 squared, and so on. So as we've seen, so I've got many corrections or mistakes, so I'm sorry for that. So let's proceed. So after all this, so we're gonna get the differences of each point. So this becomes to 0.4. So first is, so my plan is, so we're gonna get the points, but we must I can limit it to 4 decimal places. So for me is I'm gonna limit it to 4 decimal places. So for total we have 13.1974. So that's the total. So as we see in the formula, so we had to, so the formula here, so here, so n15, so we will divide it to 15, but as in the formula, so we're gonna minus it with 1. So formula, so our sample mean we can, oh sorry, so as the formula here, so we've got n minus 1, so we're gonna minus it with n minus 1, or 13.1974 over 14. So we will get, so let's rewrite it, so 13.1974 divided by our 14. So we had this value, so before that, so I'm gonna put this in another sheet of paper or bond paper for clarification. So I'm gonna write back the formula of the sample standard deviation. So the formula would be, sorry. So the formula would be sample standard deviation. So S is equals square root summation of differences between each point between the x bar or the sample mean squared over n minus 1. So since here and here, so since we've got the summation of all, which is the 13.1974, so we can plot it here, we can plug it in. So is equals to 13.1974 over, so since our n equals 15, so we're gonna subtract it with 1, so this becomes 14. So our denominator will become 14 with a kind of square root. So let's divide this both. So the quotient of 13.1974 by 4 with 14 is 0.94268. 0.9426714 So since we had this square root, so we're gonna square it. So this becomes, so square root of 0.942694267142714286. So we've got a, so at this point, so what I will include is the fourth decimal point. So we've got is 9709. So since 1 cannot be round off, so it could stop at 9. So 0.9709. So our S, or sample standard deviation, will become 0.9709. So that's it for the sample standard deviation. So since we had our sample mean and our sample standard deviation. So let's proceed now to find out our but wait, so let's try to see our to look at our formula. So since we have now the simple standard deviation and the x bar or sample mean, so what we'll find now is this portion or the t-score from the t-table. So for finding this, so we need to find out the t-value or the t-score of this. So this also has alpha over 2. So let's try to calculate this. So since we had our sample standard deviation and our average mean or our sample mean, so what is our problem now is we're gonna find the t-score. So first is we're gonna find the degrees of freedom or the df. So in finding the df, our formula is just df or degrees of freedom is just simply n minus 1, or n is your sample size. So n minus 1 is equals to 14. So that's our degrees of freedom. And second is we're gonna find our or which we called as our t-score. So since alpha is so since alpha is 0.05, so what we need to do is to find its or to find its which tailed could be. So if we will divide it by 2, so we can get a 0.025, which can be seen in the two-tailed value. So two-tailed. So but if we let 0.05, so we can also find it as 95% confidence level. So to find this, so we can use or we can open out our t-table. So as we see, so our t-table or our the value of the 0.25 two-tailed or the 95% confidence level is t or t-score is 2.145. So that's the value of our t-score or t-value. So since we had all the needed given points to proceed now to our formula, so we cannot proceed it. So I'm gonna rewrite all the given. So we had our also it can be seen in this in the picture in the video. So it is okay to proceed. So for last time, so I'm gonna proceed it. So PIR prediction interval is equals to sample mean or x bar plus or minus special t, or this is the value of t, alpha over 2 times s or sample standard deviation square root of 1 plus 1 over n. So since we had our x bar, our sample mean, so sample mean is equals to 3.7867 plus our t-score is 2.145 plus or minus, sorry, so and our S or sample standard deviation is 0.9709 times square root of 1 plus 1 over, so since our sample size is 15, so we're gonna put out this 15. So this comes, so first thing, so we can calculate it to the calculator for less time consuming. So we're gonna use the calculator. So 3.7867 plus 2.145 0.9709 times the square root of 1 plus 1 over 15. So this equation becomes 5.93. So 5.93. So at the third, or at the third decimal place is 7. So we're gonna round it off. So it becomes 5.94. So it becomes 5.94% prediction interval for drying time of next trial of paint. So at least, so I'm gonna put some add-on. So this plus or minus, so it can vary. So in this video, so as I had seen for that video, for an example, so she add it. So I don't know why she add it, but I'm gonna do some research and I will add on some information after this video. And then, so that is how to find the prediction interval when standard deviation is unknown or sigma is unknown. So that's all, and thanks.